Yes, welcome back class. We are still going on with our topic which we introduced earlier, which is length, mass and capacity. Though we started by looking at length, we looked at the different units in which length is measured, we looked at perimeter and defined it as the total distance around any figure. Now we're going to look at another aspect of length which we call area. So we're going to look at something called area. Now, to begin with, what is area? Area is the size of a surface measured in square units. Area is the size of any surface measured in square units. Now, when I talk about area, maybe you can use an example of your class. I may ask, what is the area of this particular class, of P.6 Mathematics class? Now, what I mean is, the surface occupied by this particular class of P.6 Mathematics is what we call the area of the class. In other words, when I say the area of the class, I mean the total surface occupied by this class. So, when we're looking at area, there are different figures or polygons, and they all have different methods or formulae by which we find their area. For example, a rectangle. We shall look at the area of a rectangle. We have a square. There's also the formula for finding area of a square. We have triangles. There's a formula for finding area of a triangle. We have trapeziums. We have rhombus. We have parallelogram. So maybe we can look at the different figures and maybe how to get their area. Maybe rectangle. We know that a rectangle is in this format. So the area of a rectangle is equal to length times width. And we know that in a rectangle, down here is where the length is and here is the width. So when we're looking for the area of a rectangle, we get the length times the width. When we come to a square, now remember that a square, all the four sides are equal. In a square, we know that all the four sides are equal. So the area of a square is got by getting the value of one side and multiplying it to the value of another side. This is one side, this is another side. Remember, in a square we don't have length and width. Reason being, all the sides are equal. So we call them sides. So the area of a square is side times side. We come to a triangle. A triangle. When you look at this kind of a triangle, remember there are different kinds of triangles, and this triangle is what we call a right-angled triangle. In other words, a triangle in which one of the angles is 90 degrees. So this is what we call a right-angled triangle. Now, remember that in a triangle, what the surface down here is what we call the base, and right here is what we call the height. Then this other long side, or the longest side, or the slanting side is what we call the hypotenuse. The hypotenuse. Now when we are looking for the area of a triangle of this format, a right angled triangle, the area is going to be equal to a half times the base times the height. In other words, area is equal to a half times base times height. Now, you may find another triangle which is of this format, which is maybe not a right angled triangle. Another triangle which is of this format, maybe an isosceles triangle. So you are looking for the area of such a triangle. We get this from here up to here is what we call the base. Then this one is what we call the height. So when I'm looking for the area of this triangle, I'm going to get a half times the whole of this base, this one here, from here up to here, times the base times this height. We also have another figure called a trapezium. It also has four sides. Trapezium can be in that format, or it can also also be in this format. So a trapezium can either be like this or like that. So on a trapezium, what we know is we have a side here, we have this, we have the slanting one, we have this. Now, this side here is what we call the height. Same applies to what we had for the right angle triangle. So what we have here is called the height. Then in a trapezium, there are two sides which are parallel. That is this one and that one. Now, of these two sides, one is shorter than the other. These two sides are parallel, but of the two sides, the two sides are parallel to one another, but they are of different length. In other words, one is longer than the other. So the shorter side, we decide to name it side A, and the longer side, we name it side B. Now when you come to this other one, when we are looking for the height of this one, remember the height has always got to be vertical. So the height of this one is going to be around here, and that's going to be my height. Remember we said the shorter side, there are two sides which are parallel, this one and this one. The shorter side, we name it A, the longer side, we name it B. So when I'm looking for the area of a trapezium, either this one or this one, the area is given as a half times the h, which is the height, into the short side plus the long side. So the area of a trapezium is given as a half times the height into the short side plus the long side. We have lastly another figure called a parallelogram. Parallelogram is drawn in this format, whereby this side is parallel to this side. Then these other two, these two are also parallel to one another. So this side is parallel to this one, even these two are also parallel to one another. So when we are looking for the area of a parallelogram, the area is given as base times height. What I mean by the base is right down here, just like we had for the triangle. The base for this is going to be here. That is my base. Then the height, remember we said it is vertical, starts from here. That is my height. So that is how we find the area of different figures or polygons. Now out of all these, we can choose one and maybe do an example about it. For example, maybe area of a triangle. So if I have my triangle in this format, my right angle triangle, I have 8 centimeters here, I have 6 centimeters, and I'm required to find the area of this triangle. Now, remember we said the area of the triangle is given as a half times the base times the height. Now we say that the base is this surface down here, which is 8 centimeters. So the base is 8 centimeters times the height here, which is 6 centimeters. So when I first multiply these ones, or I can reduce by 2, 1, by 2, 4. So I have 1 times 4, which is 4. Then 4 times 6, which is 24. So my area is going to be 24. But when you multiply centimeter and centimeter, you end up with centimeter squared as the answer. So you must be careful about the units. Remember we said area is measured in square units. If it is centimeter, it should be centimeters squared. If it is meters, it should be meters squared. Okay. Now, after that, maybe we can look at something else called area of a shaded part. Area of a shaded part. Area of a shaded part. So from this, If I have an example, maybe this one. Here I have 5 centimeters, then I have 2 centimeters, down here I have 10 centimeters, and here I have 7 centimeters. So my shaded part is this one. So I'm required to determine the area of the shaded part. When you look at these two figures, we are having two rectangles. One is outside, the other one is inside. So I'm required to find the area of this shaded part, the one which is between the two rectangles. So when I'm looking for the area of this shaded part, I get the area of the outer figure, I subtract it from the area of the inward figure. So I'm first going to get the area of the outer rectangle. Remember, both of these are rectangles. So I'm going to get area of the outer rectangle. The area, we start by looking for the area of the outer figure, which is a rectangle. So my area, remember I was saying area of the rectangle is length times width. So that is length times width. Now, what is the length of the outer rectangle? It is this one, which is 10 centimeters, times the width, which is 7 centimeters. So 10 times 7, we get 70. Centimeter times centimeter, we end up with centimeter square. So the area of the outer rectangle is 70 centimeters squared. Area of the inner rectangle. So my area, remember, the area of the rectangle is length times width. Now, when you look at this rectangle, the length of this inner one is 5, whereas the width is 2. So my length is 5 centimeters times the width, which is 2 centimeters. 5 centimeters times 2 centimeters, I get 10 centimeters squared. Reminder, don't forget the square on the centimeter. It is very important. So after I've done all that, I now determine the area of the shaded part. Remember, I first looked for the area of the outer rectangle. We have looked for the area of the inner rectangle. We now determine the area of this other part which has remained. So the area of the shaded part is going to be the area of the outward rectangle minus the area of the inner rectangle. So area of shaded part, the area of the shaded part is going to be equal to the area of the outer rectangle, which is 70 centimeters squared, minus the area of the inner rectangle, which is 10 centimeters squared. So 70 centimeters squared minus 10 centimeters squared, I end up with 60 centimeters squared as my answer. So I've said when we're looking at the area of a shaded part, you first determine the area of the figure which is outside, then you also determine the area of the figure which is on the inside, then you subtract the two areas for you to get the area of the shaded part. Okay. Meanwhile, I hope you've seen how we look for area and how we determine the area of the different figures. Thanks for listening. We shall continue from there next time.